We are going live on Facebook on this session with David Cuartielles from Arduino. And hello, David. What will your session be about today?
Well, the idea is to challenge a bit the whole concept of IoT as a connected scenario. Like, people tend to think that this whole idea of capturing data and so on always has to go through an online platform. And but I think that's sometimes complex to understand from a pedagogical perspective. So I'm building a whole tutorial that will get people from zero to have their own personal closed network. Closed, not learn how it works. Yeah, so today we will just do one part of this tutorial because in 2 hours you can go super far, but we can at least introduce everything.
Okay, great. I think maybe you have some internet connection issues, or it is if you think that you're facing internet connection issues, you can turn off the camera if needed. Otherwise, I will make you now a host.
Actually, before we start, just don't leave yet. I'm going to change internet connection to make sure.
Okay.
I have a super reliable connection if I change in a second, just to not face any problems during the whole thing. Just need to change. So I might lose connection for like 20 seconds while I change network.
In the meantime, Naz, could you make me co-host and Abhinav as well? Abhinav's already set up. Okay, great. Done.
Okay, I think I'm live. I'm done.
Yes. So basically, we are introducing you to this session, and Luciano, you are host, and Abhinav is co-host. Do you want me to switch these two?
No, it's fine. I'll make David co-host and I'll keep.
Okay, perfect. Have a great session. Bye-bye.
Okay. So hello everyone. Before we start, I think we are like 15 people online. I would like we're gonna use the. I'm sorry for the Facebook viewers because they will not see everything. We're gonna be eventually doing. So, but I would like to just ask you to raise your hand through Zoom for a second, just to see that you master the tools, because I will be asking questions. It would be great if you can just answer. So at the count of 3, can you raise your hand on Zoom? Which means look for the option how to do it. Yeah, Dean made it. Yeah. So that most people, yeah, I would like any kind of interaction, either pressing yes or raising your hand will work. I mean, I also would like you to try it out so you can feel free to ask questions at any time and interrupt me and just raise your hand and then I give you voice. Or you can also chat if you don't want to like talk. Okay, great. I will also open the chat here and we have some people saying hello from Montreal and India. Dina from CMU, Urbana, Illinois, Lady in the Netherlands, and Birmingham. So hello, everybody. And hello, everybody that are watching from Facebook or other stream platforms once this has been recorded. As you know, I'm David Cuartielles, co-founder of Arduino, and I'm here to talk about how to make your own, I call it old school internet, but IoT, sorry. But the idea is to provide people with tools to be able to, by themselves, build their own connected devices and build their own servers to receive information from these connected devices. And I approach this as a pedagogical endeavor, which means that my goal is not to make the most reliable, most secure crazy connection system. My idea is to help people understand how it works. And this is challenging because the more security and engineering is put into these systems, the harder it becomes to understand what's going underneath. So I'm going to be building these tutorials over the next months. For today, what I have is a tutorial I made a couple of weeks ago for the Ireland community, which is a Mexican online conference. And I was explaining how to build this thing from scratch. So we have 2 hours. And in 2 hours, I think we can go as far as getting data from a sensor and send it to a computer and graph this information on the screen without going out on the internet, without going to a server anywhere, just sending information from one place to the other. And in my recommendation for this tutorial, I asked people to get a specific board for a reason. It's not so much that I make the boards, but it's that I know the system works with that particular board or that particular family of boards. So if you have them, you have one of those, you're more than welcome to follow me step by step and interrupt me at any time. If you don't have them, then this will be more of like a bit more boring kind of tutorial for you because you cannot interact while building stuff, but it's up to you. So what I'm going to be using is this combo here, which is a combo of a MKR1010 from Arduino, which is a board that has a Wi-Fi and Bluetooth chipset. This thing down here is a Wi-Fi and Bluetooth chipset. And this is the main processor of the board. That is the one that makes the operations. This is the one we program. And this board also has a battery connector and an external connector for other sensors outside. And we're going to use a shield, which is a board that you put on top of the board. And this one has a bunch of environmental monitoring information sensors. So it has like barometric pressure, temperature, humidity, and also light intensity and light radiation. So it gives you UVA, UVB, the looks, and so back and forth. And it also has the possibility of storing things on a micro SD card, but we're not going to see that. But yeah, I have it here just because I use this board quite a bit. So the idea with this is that you will be able of getting information from a sensor and then send it from your board to the computer and show the data. And I have prepared let me just share my screen. I will going to be showing my screen all the time, so you will not see so much of my face. Well, I can fix that somehow. I think I might not have the right to share the screen. You have to give me the rights to do that. Since I'm just co-host, I think you have to personally click on me and give me the rights. So I'm going to be showing the screen, and I'm going to be showing you code that I will, some already made tutorials for Arduino and processing. And I like to use this combo of Arduino and processing because they work out of the box in every operating system. Okay, so let me just try to share my screen now. And I still, when I click the button sharing, I don't get the right to share.
So you should have the right to share.
It's not letting me.
Maybe
we can try the classic. I leave the call and I come back.
No, it's okay. Worst case scenario, I'll make you host. But let me see. I'm changing one more setting here.
Yeah.
Can you try now?
No. Doesn't let me. Let me turn off my camera to see. Like no. This is very.
Okay, so you are now host. I don't see any issues from this side.
Yeah. Like I'm getting, sorry. You know what? I could share from the beginning. I made this classic mistake on Linux. It happens to me often. Like I put the call as an always stop window. And I was like, I don't see anything because the window was behind me. So, so all my bad, sorry. So let me just start by sharing my my browser, and this is the URL for the GitHub project where I have stored everything, and I'm sharing it on the chat for people that are in this call. For people that are not in the call, you can just search for Old School IoT with underscores inside GitHub, and we will show up. I'm seeing the only person that claims that can make Old School IoT, which is a very almost controversial way of calling things. And as I said, I prepared this. The goal is to grow this tutorial into something that will end up with a web server with data and so on. That is not included here yet. Okay, we're just gonna see the first step. And in this folder, you see an explanation about how everything is done. And you see there is a subfolder that says Arduino and one that says processing. The Arduino one contains code to run on Arduino boards and try step by step how to send data. And the processing one includes also step-by-step examples on how to increase the complexity on how you get the data and you graph the data. And so today we're gonna have enough time to navigate through all of this. As I said in the call, you can use any kind of sensor. You use a, I don't know, LM35 temperature sensor, which is a very common sensor. It's an analog sensor. You read an analog signal and you can take that number and send it through the Wi-Fi back to the computer, for example. And you could as well take multiple sensors and send them. So what I'm going to do is actually take all of the sensors that I have in my board, which are a bunch of them, and send them back to the computer and graph them. And as for reliability, well, I will try not to make a lot of product placement in this workshop, okay? I mean, being the guy that, one of the guys that made Arduino and talk about Arduino, it sounds a lot like marketing, but I will try not to make that. I will just focus on what is important. But I have made some tests of this particular combo of boards, and I would say they're pretty sturdy. Like the environmental shield, I've put it on a balloon that we shot in the atmosphere and went up 42 kilometers. And the thing kept on tracking data and mapping data the whole way. So it can handle pretty low temperatures and pretty high changes in barometric pressure and so on, and work fine. So, so I would say this is the perfect monitoring device for a lot of your projects. So the first thing is that in order to run these examples, you need some libraries. And the way the communication is going to happen between the computer and Arduino is over Wi-Fi. But on top of the Wi-Fi, we need to run something. And the way we're going to do it is using WebSockets. In order to have this exchange via WebSockets, you need to install a couple of things on the Arduino side and on the processing side. It doesn't just work out of the box. Also, because if you are not having the core for this particular board, it might not work from the start. So let me just open, right now I'm just sharing my browser. So I will now open Arduino and processing, and then start showing you how everything works down here. So let me just see where I have the full display to share. Okay. Okay, for some reason I can only share a window at a time, so this is going to be very interesting. But let's do it. So this is the Arduino software, and I will just maximize it. Here. And I wonder, oh, wait. Do you see the full window or just half the window? Because I think I see a green line.
Yeah, there's a green line going through it at a certain point, but we see everything.
Okay, let me just start again so that you don't see the line. Here you go. Okay, so this is an example that connected to the environmental shield, is how this shield that I'm having here is called. It will send the all of the data back to the computer via the serial port. And as you see in the code here, this to read the, thanks to the library that runs the shield, to read the temperature is as easy as calling the function read temperature. Humidity is read humidity, read pressure, illuminance, UVA, UVB, and UV index. So it's like super easy. And it shouldn't be more complicated than this. And the sensors, they work at different levels. Some of them are I2C, some of them are analog sensors. At this point, you don't need to care about it because the readings are done this way. And so this MKR, M stands for MKR Environmental Shield Library. You need to install it. And the way you install libraries on the Arduino software is by going to program, include libraries, and call the library manager. And the library manager will show you all of the available libraries for Arduino. And you just need to search for MKR ENV. And it shows here, okay, there is the MKR ENV library by Arduino version 1.1.0. I have it installed, so I don't need to install it. But if you don't have it, you need to install it in case you want to use this particular shield. And if you're not using the shield because you have your own sensors, then you don't need to install it. That's then forget about it. Okay. Then on the other hand, because we're going to be using this Maker 1010 board, which is running on the SAMD21 microcontroller, you might not have that board by default in your tools. You can check in tools and check which boards you have, and you should be able to see here whether you have it. It doesn't come with the software by default. As you know, each family of boards requires a new compiler. Compilers are really heavy, and as part of like usability, or trying to make the software as usable as possible for our users, what we do is that we don't provide all of the compilers at once because that will be a really big download. Will probably be an inconvenience for people, for example, sitting at locations with low connectivity. And so we only provide the default compiler for the most common Arduino boards, which is like the Arduino Uno, which is this one. And that only weighs 100 megabytes. But the one for this one weighs another 400 or 500 megabytes. So that extra download is only if you are going to use it. So the way you install it is by going to the boards menu and check out the boards manager. And here you can just search for the kind of board you want to use. So if I want to use the MKR 1010, which is the one I'm going to use, I write it here and it tells me, okay, there is a package called Arduino Assembly Boards. And the latest version here is 1.8.2. Oh, there's a newer one. I can update it and so on. You will realize I have the software in Spanish because my computer is configured in Spanish. You will see this in your own language or in the language you have your computer configured in. So I could choose to update it. I'm not going to do it right now. I don't know what is the latest update, but I know that tutorial works on the current update. So I'm going to avoid the demo effect of putting the latest update just before a show. So if you have the right board, that will take you 10 minutes tops to download. Well, it depends on your connection, but hopefully your connection is not too bad. And you have the right libraries for whatever sensors you're using, then you're ready to use your board and read the data and at least show it on the screen. So I'm gonna get a micro USB cable. I have a whole bunch of cables down here in my desk. Sorry for this. And with this micro USB cable, I will connect the board to my computer, program the board with the software, and then see what happens with it. So connect the board to my computer here. This code, by the way, that I just opened is one of the basic examples of the Maker environmental shield. Like you can check on files, examples. Once you have installed the library, it will show up here as MKR environmental shield, which is here, Arduino MKR ENV. And you have read sensors and read sensors imperial in case you don't like the metric system. You can always change to the other one. This is the read sensors example. And so the read sensors example allows you to read all of this data and send it via the serial port to the computer so you can read it on your screen. So let's just upload the code. If I have chosen the right board and the right serial port, I can just click upload. And in a couple of seconds, this code will be up on my board. Okay, so there you have it. So the next thing I can do is to open the serial port monitor and check the values coming into the computer. And I guess you don't see this part because I'm only sharing, I'm not sharing my full desktop, I'm just sharing my software. So I'm gonna reshare with you the window that's showing the data. There you have it. So that's the information that is coming from the board with all of these sensors into the computer. But this is happening through the USB cable. And what I want to do is to change the situation and send the data via Wi-Fi. So I could eventually send the data to other programs. Like for example, I could make a node server with JavaScript and get the data over WebSocket, for example. Okay, so there is multiple scenarios. We're just gonna choose one and we will work with that one. And you see here, the temperature in this room says it's 30 degrees. Well, that's not exactly true. It's actually kind of warm, but not so warm. It's because it's getting straight the fan from my computer, blowing straight on the sensor. But I could just remove it from there and blow on it. And you see how the temperature changes, as well as humidity and so on and so forth. So then you can imagine all the possibilities you have with this. You could be, sorry, I keep on getting the mouse that belongs to another computer. And so you could be tracing this information and then storing it on an SD card or storing it on a file in your computer, for example. We have a tutorial on the Arduino website called IoT Prime. If you look at that, you will see how to, for example, get this data and push it into an Excel spreadsheet. So that you can then analyze it over time on an Excel spreadsheet or whatever. Like you first store it in a CSV file and then on a spreadsheet later on. But I'm more interested in not after the fact monitoring, but in real-time monitoring. I want to see the data as it happens, and I want to see it not as text, I want to see it graphed, and I want to have the possibility of graphing this data easily. So what would be the next step? So going back to the browser, where we have the information about the different examples that I prepared for this talk. If you go into Arduino, you see that there is 3 different examples. There's one example that's called Simple WebSocket. There's one that is called Environmental Shield Data WebSocket, and then one that is called Many Boards WebSocket. These examples are guiding you step by step through the idea of getting data and sending it via the wireless connection. We're going to use WebSockets, which is a way of packaging data and sending it between 2 points. Then there is also the idea of sending not just whatever data, but sending the environment sensor data, which is the sheet I have here has multiple sensors, and get all that data, package it somehow, and send it via WebSocket. And then you can have one board, or you can have many boards. If you have many boards, then you want to distinguish between the boards. You want to have maybe a temperature sensor close to the entrance, one in the kitchen, and one in your greenhouse, or whatever you have your plants or whatever. So then you need to have multiple, and you can share the same communication channel, and then just distinguish which one was the one sending the data by having a certain variable that is an ID number. So you can distinguish them by a certain ID number. As I said earlier, I'm not concerned, I'm not looking at all into security or anything like that. That is very important, but adding all of those things to a tutorial like this will make it very complicated, okay? Just keep it in mind, whatever we're seeing today is for you to build at your own risk in your own personal closed network so that you don't put it out. You might be interested in sharing it anyway. So let's take a look at what this simple WebSocket example does. And simple WebSocket example, the first thing that it's going to do is going to connect to the Wi-Fi, and then it's going to be connecting through some sort of security that exists on the network already, like WPA or WEP, which I hope nobody has because it's the most hackable network in the world. And so Arduino secrets is a file that contains the SSID and the password for a certain network. So I will have to change this to be the one in my network at home. But the one I have in the example, just as a joke, belongs to a camping I was at in the north of Sweden while I was writing this example, because I wrote this example as I was on my vacation. And so if you happen to drive all the way up to Arjeplog in the north of Sweden, you know the password to the Wi-Fi. So this is the example that we're going to see it now on the Arduino IDE, but it's fully working, and there is just a couple of things that need to be changed, and it's a couple of things you need to understand. So when you establish a connection between two devices, they need to somehow exchange information about who they are. If you are going to make a WebSocket connection, the client needs to know which is the IP number of this server. So the client device needs to know which is the address, that's the IP number, where to find the device that's going to be allowing you to send data in. In this particular example, when I wrote this tutorial, the server address was this one. This is the IP number I got as I was connected to that one network I was mentioning earlier. I will have to change this to be the network that I have in my computer in the current network. So the examples are not just copy paste. You need to change a couple of things. You need to make sure you know which is the IP number for your computer, and then you need to know which is the login and password, sorry, the network name and the password for the network you're going to be using. But there is some limitations, and this is important, and I need to mention this because some people otherwise will find issues at some point. So there's some limitations, like for example, you might have in a Windows computer, very typical, something like the McAfee security system that has a firewall that will not let you connect to WebSockets or to the specific port where the WebSocket connection is gonna happen. So you will have to open that connection so that you can then use it in your examples. You might be in a network that doesn't allow at all doing this because it has captive portals, like happens at some universities. So your board cannot connect to a captive portal network. It needs to connect to a network that just has SSID and password. So depending on the scenario you're connecting to, you need to make sure you can fulfill all the requirements so you can actually connect and start working. Okay, so I will cut the talking or I will continue talking, but as I'm coding. So I have all these examples in my computer already because I've been using them before. So I need just to open this particular example before I share my screen. Just find it. Okay. I don't know what it is. So I'm gonna then go step by step and show you how you have to do it if you start from scratch. So let's say that you don't have this example. Then what you need to do is that you need to download the folder from GitHub and bring it to your computer. if you're in the basic folder, you can just click on download the code. You download it as a zip file, accept, and then you can decide where to extract it. So you have this 2020 Ireland folder. So I'm going to extract it, for example, on my desktop. I don't have a lot of stuff on my desktop, so I will extract it there. And you didn't see how I extracted on my desktop because you cannot see how for some reason, I cannot share my full desktop. So, but if I show you my desktop here, you see I extracted this folder called 2020 Ireland. And inside of it, I have code for the 3 examples for Arduino, as well as different examples for processing. So if I open my Arduino example, Ireland simple WebSocket, if I double click on it, it will automatically open the Arduino software, as I'm going to show you now. But before I do it, I'm going to change the network information to my network home. And I'm not going to share the screen without you, with you, as I'm doing that, because I don't want you to see my network information. But now I did it. Okay, so this is the code for the board that will run on the board to just make a simple WebSocket connection. It's the same you saw on the server. I have changed the Arduino secret information. You should do it as well. And now I need to change which is the server address. The server address for my computer, the server address is the address for my computer, which is the one that's going to act as a server, while the Arduino board is going to act as a client. So which is that server address? Well, I need to check, and I'm going to do it through a terminal window. So let me share with you the terminal window so I can show you. I'm running Linux in my computer. If you were running any other operating system, you can also check the IP number. I will just call the command ifconfig that tells you information about the different devices on the network, or the different, how your device connects to the network in different peripherals. And from the peripheral Wi-Fi board, I connect with the IP number 192.168.43.232. So I can copy this, and I'm going to use it on my Arduino code as the server information. So here's my Arduino code, and I will just paste here the server information. So this computer, which IP number is 192.168.43.232, is the one the Arduino board will connect to. So the board in its software needs to know the address. On top of that, we're going to connect through the port 8025. So I need to make sure that my computer has that port open. You should not use ports like port 80, for example, because port 80 is used for web connection. Port 21 is used for FTP. 22 is used for secure connections, SSH connections, and so on and so forth. So it's recommended to use something above the port number 8000 for the connections on the WebSocket examples. You need to have different libraries for being able of running this particular piece of code. The same way we installed the library earlier for the environmental shield, you need to install a couple more libraries. First, you need to install the Arduino HTTP client library. That one gives you a layer that allows you to do different kinds of HTTP connections, which is how to exchange data between devices on a network. In this case, we use this to be able of having WebSockets. On top of that, there is this one called Wi-Fi Nina. And the Wi-Fi Nina library is the library that controls the radio chip on the Arduino MKR1010. And that makes the connections at low level. So it's the one that connects to the Wi-Fi, it's the one that sends bytes depending on the protocol you choose and so on. And then Arduino_secrets is the secrets file that is here that contains the network name and the password for the network I'm using here. When installing the Wi-Fi Nina library, you can have a Wi-Fi client object, which is called Wi-Fi. And on top of this one, you will be able of building a socket connection and so on and so forth. So you see here, the WebSocket Client allows me to create a socket object that will be on this Wi-Fi connection that will connect to the server address that we declare up here and on the port we declare as well. So what this does is to create a virtual wire between the board and the computer in order to be able of sending information back and forth. Okay, so this just sends data back and forth. The rest of the information here is just a step-by-step explanation of how things work. First, it opens the serial port connectivity to be able of reporting back and see what's going on. If it's not connected to the network, it tries to connect, and we'll try to connect to the SSID. Once it does that, it tries to, first it's printing out on serial port, I'm trying to connect. Then it makes sure it is connected, and then it actually connects. So that's how it works. And then it prints information of the connection we just made. On the other hand, it gets its own IP number and it prints it out on the serial port so that you know which is the IP number your board got when negotiating with the network. After that, if the network is disconnected, it will try to connect again. In this case, if once it's connected, it will continue. And when it's connected, it will try to send the command hello. It will print hello as a text to the WebSocket. So client is the object, is the virtual wire that connects the board with the computer. You can use different types of methods that will allow you doing the configuration of what's going to happen. So you begin messages saying, we're going to be sending its text message back to the computer. Then we print hello. Then we print a count, which is a variable that will be a number. And then we end the message. So this will be printing hello 0, hello 1, hello 2, hello 3. And then the computer should be able to read this information and use it somehow. So I remind you, what we want to do is to send something from the board into the computer. On the other hand, it will also try to get a message from the computer. So the computer will be sending something back. And when it gets a message, the parse message function will get it down and store it. Store the amount of bytes that are available in the message. And if the amount of bytes is bigger than 0, which means there is some data that arrived, then it will get all of the message at once and print it out. The way to get it is with client.readstring. So you see client is working for sending, but also for receiving. And if you're familiar with Arduino code and you're familiar with the serial port, you know we have a function called available, which means that something arrived through the serial port. This parse message is doing the job of actually getting the message and telling you how long the message is. So it's kind of like available in a way on the serial port. After that, it will wait for 5 seconds. You will disconnect and then try to connect again, send hello, and so on and so forth. So every 5 seconds, it's going to be sending something to the computer. So let's put this on the board. What's important is that once we have this on the board, if we don't have anything on the other side, nothing's going to work. So we need to have something on the computer side to make sure that information is coming through. So now the code is running. I will stop sharing because I need to open the serial port monitor and then share that again with you. So I open the serial port monitor. And now I on Zoom share my screen with you. Again, just to share that other window. And you see here, it's trying to start the WebSocket client and disconnecting from it. This is what happens once we are already inside the program. The program first connects to the network, gets the IP number, and then starts to tell you that the connection is working or not working. I want to make a change on the code so that you can actually get the program to wait until you open the serial port monitor to see the whole process, because we missed a part of the process. Okay. So here you see the code. Here we start the serial port monitor, and we can say here that while, you can see here that while there is no serial signal, then you do nothing. So it says basically until the serial port is open, just wait here in the code. Once the serial port is open, then you start doing the rest of the commands. So we can see the full configuration of this program on the screen. Okay, so now this has been programmed, it's uploaded. I stop sharing, I open the serial port monitor again, and I share the screen again. And here you see, this is what it actually happens. So first, it tries to connect to the network. The network is called David. I'm not going to tell you the password. And it gets the IP number 192.168.43.40, which is different from the one for the server. The server had a slightly different number. It was the same network and everything, but it was 232. And it tries to connect to a WebSocket server. That's because the board is a WebSocket client, but there is no server connected, so nothing happens. So we don't get to send hola, and we don't get to receive anything back, or hello, sorry. So on the other hand, I need to have my computer to start the WebSocket server and get the information and show it on the screen. As I said earlier, I'm going to be using processing for this part. I really love to use processing for my examples. I've been using processing for 15 years now in class. It's a super easy way to teach people how to get started with programming, and they can do really advanced things. And everything they learn, is portable to other programming languages. Sometimes verbatim. Sometimes you can copy the code as it is and just bring it into a different context, and it will work. So, and also it's really well supported. It has a great, super inclusive community, people developing for it, and it's making the right migration from Java into JavaScript at this point. But it also supports Python mode, Android mode, and a lot of other stuff. So after this commercial break for processing, which is an open source project I really like, I'm gonna start using it to get the data from the board into the computer. So I actually prepared a little bit. So I had my processing software open somewhere. I just didn't have the right program open. So let me just find the right program so that we save a bit of time. Okay. So I have it here now. I will share the screen with you again. And here we go. So here you see the Sketch00 WebSocket server that is also on the GitHub repository that you have downloaded. And the only thing this program does is that it configures a WebSocket server, and then it allows you to receive data and answer back. It does very little at graphical level, and it's a basic example that is coming with the WebSocket library. So WebSocket library, in this case, is something that you need to install for processing. You need to remember that processing and Arduino are not the same thing, even though the IDEs look very similar, because the Arduino IDE, the classic one, is based on the processing IDE. And this brings people to confusion. So you remember they have different colors. The dark blue is processing, the light blue is Arduino. And processing software is, at this point, the one I'm going to be using here is Java. But the syntax is identical to the one in Arduino. So if you know how to program one, you know how to program the other. There is semicolons at the end of each command. There is curly braces for opening a function. There is parameters separated by commas. So everything is the same. Only that one is Java, which is the processing one, and the other one is C, which is the Arduino one. So please be careful, don't mix up. And the way you import libraries for, the way you import libraries into your software, it's all by going to Sketch and clicking on Import Libraries and Add Libraries. And that will open the library monitor for processing. And here you can just search for WebSockets. And WebSockets, I'm not sure you see in this window right now, because I have this problem that you only see a part of the windows I'm using. So I'm just going to share the actual contribution manager window, which is this one. So this is a contribution manager window for processing that you open by going to Sketch, Import Library. And here you just have to search for WebSockets, and it opens this single one and only library from Lasse Stenbock Vestergaard, which is called WebSockets. You need to install this library. It's everything you need, and the rest of the processing part is completely standard. So this library will do the whole connectivity for you. So let's move on. I have it installed already, and taking a look at the code. So here you see the code, and first we import the WebSockets library. This imports all of the methods and classes existing in this WebSockets library. Then we create a WebSocket server. Remember, the computer is going to be the WebSocket server. We call it WS. And we declare a couple of variables. The WebSocket server needs to be instantiated, and you do that inside the setup. And it's going to run in this class on the port 8025. You remember this from the Arduino program. 8025 is the way, is the place where the connection is going to happen, that virtual wire. And it will happen at the bottom, like it will show up like no strange added URL. So the URL for this is 192.168.43, I think, 232, colon 825, and no slash anything. Okay, that's empty. And this program, it's gonna be, what it's doing here is counting the time. So every 5 seconds, it's gonna be sending the message over the socket server message. So this will be making sure that there is something sent back to the Arduino board all the time. And we will be able to see this on the Arduino serial port monitor, okay? On the other hand, when there is a WebSocket event, which means something arrived through the WebSocket, it's going to be printing that down here on the console area. And also will be drawing a circle at a random place on the graphical interface, just to show that you can do something with graphics. Okay. So if I run this program, now the program is running. Okay. And the server started, and right now it's not getting anything. You can check down here in the thing. Oh, now it got the first hello. So now the board is connected. It connected and sent hello 0. Remember that we said it's a counter, and now it's hello 1. So it's slowly starting to work. So now the server is getting data from the client. So this is the first step. This thing is connecting wirelessly. This board is connected through the Wi-Fi to this computer. You of course see the USB cable. You can use the USB cable for debugging, but believe me when I say that this data is actually flying through the air, going to my phone that is acting as an access point, and from the phone going back to the computer over the Wi-Fi and pushing the data in. So I could just unplug this board and put it somewhere else in my office and still get data streamed in. It's also interesting now to see what's going on at the client level. So at the client level, we have the Arduino board, which is, I don't know why I put now the window down here. And I have to open the serial port monitor again and show you that the Arduino board is also getting information back from the server. Okay, look at this. So this is the window from the serial port monitor, and you see I say sending hello and the number, and I receive a message all the time. It's called, it says server message. If you remember, server message is what we were printing or sending to the client, sorry, on the processing sketch. So now we have a bidirectional communication. The board is sending to the computer, and the computer is sending back to the board. This is really cool. So this is the very basic step. This is the first stepping stone towards building my own IoT. I have a wireless device sending data through a wireless connection into a program that I wrote myself. It's great. Next step, I want to send meaningful data, not just a counter. So I want to send the sensor information from my board into my computer. And then as a next step, I would like to graph this information in a nice way on the screen. So nothing stops me from changing the code on Arduino, which right now is pretty ridiculous because it's just sending hello and a number, to be something more meaningful, like, for example, the information from the sensors. And that's something that I did when I crafted the following examples that I prepared for you in the repository. You saw that there was, let me just go back to the examples. Yeah, this is the folder of examples. And you saw that I have another example called Environmental Shield Data WebSocket. And this is the next one. And this one, what it does is that instead of saying a random text, it's actually sending sensor data, which is what we want to graph, what we want to look into. So I double clicked on it and I'm opening the file. And 1 second before I continue, I will just change the secret information for the network before I share the screen with you. Okay, and I will maximize the window so we don't have any issues later with this. And I share the screen again. So this next example here contains everything we had before mixed together. So we saw the environmental shield example earlier that could get the data from the sensors and print it to the serial port, and the one that connects to the WebSocket server and sends the data. So we're gonna blend those two together, and then we're gonna be sending the data from the Arduino board into processing. The next step, once I have the real data, is to get the data into processing and graph it somehow, and not just stop at the level of just showing the numbers down in the console area. Well, as we continue, somebody is asking where you get the recording. I think that Fabex Live is going to be putting the recordings online at the end of the events. So I'm pretty sure you will find them there whenever you want them. But going back to the example, as you see here, the code, we have to import the same library as before, Arduino HTTP client. We have the same library for connectivity, which is the one that commands the Arduino board's Wi-Fi chip. We have the Arduino secrets, that is the one that contains information about the network that is up here. And then we have the one that we saw earlier, which is the one for the environmental shield. I insist, if you don't have the environmental shield, you don't need this library. You could just be reading an analog value from a pin and be sending this through the Wi-Fi anyway. Okay, I like to use this one because I'm actually building, I'm monitoring my greenhouse, or my plants more than my greenhouse. If you remember, in the previous example, we changed the IP number to the server, and I'm gonna copy it again from the place where I took it earlier. I will spare you the time of seeing me doing that, because you can see how I change window anyway. And here it is. Okay, we're gonna operate on the same port 8825, so we'll have to change anything on the server. This is the server address. It's the same port. And in this case, I will also use the environmental shield. So I will actually wait until the environmental shield is set up. I do the whole connection again as I did earlier. Everything is exactly the same, except for here, when I'm gonna send the sensor information, I read all of the sensors. I print the information so I can see it on the serial port, but I also prepare this long message that I send through the WebSocket. So I'm gonna send a message as text. I'm gonna send the temperature, then a comma, then humidity, then a comma, and so back and so forth. So this will make a very long string of data. And I said string intentionally. It's not an array, it's a string, it's text that will contain the numbers for each variable separated by commas. Then at the computer side, I will get the string of data and I will have to parse the data out of that string with commas. Yeah, and we're gonna see this step by step. You will understand everything. It's super easy, actually. Then you will be able of building on top of this in whatever way you want to. And everything's the same. So I can also receive messages. The communication still be bidirectional. Okay. So I'm sending this to my board that is still connected to my computer. And once I have it, the first thing I will do is to open the serial port monitor to just see that the communication is working fine, that the board is configured, that it connects to the network and so on. And then we'll check on the processing side and see how data is looking like. Okay, so this is uploaded now. I have, as usual, to stop sharing the screen so I can open the serial port monitor and then share with you the serial port monitor window. And here you go. So right now it's trying to connect. It connects after 2 attempts, and now it's sending the information for all of this data. First temperature, then humidity, pressure, illuminance, and so back and so forth. So if I go back to processing, the same server that worked before should work now. Should be getting the data and should be printing data at the bottom of this sketch. So let me just find where I put that particular example. 1 second, it's here. So this is the WebSocket server. Let me just share the screen with you. And now you see, what you see at the bottom here in the console is the data from the sensor. First is temperature, 27 degrees, humidity, 48%, and then barometric pressure, 101, I'm at sea level, and then it's a bunch of information about light, UV index and UV light, UVA, UVB. The first one is lux, actually, and so on. So right now, I'm sending all of the data from the shield all the way into the computer. Next step is getting this information graphed in a nice way. As I said earlier, processing is working with Java, and I like to use it because it's designed to work very easily in learning about how to make animations and graphs with software. So you learn how to program as you use it, which is, in my opinion, a very strong value. But because we're sending things through a WebSocket, you can also send straight into a browser. If you had a Node.js server that will accept the WebSocket connection, so it will actually take the connection from board. So if you are more familiar with WebSockets in JavaScript, you're of course welcome to try that out as well. I'm not going to do it in this example, but it's possible and it's fairly easy. So we saw that the data is separated by commas. There is a command in processing that is called split, and split allows you to find inside a string or it looks in a string for a certain symbol or character or a set of symbols that act as a separator. The separator is it's a symbol that puts the different items of information together. In this case, is the comma. So in the following example, we're gonna see how there is a bunch of code dedicated to do that job. And right now, let me just show you the browser. Here it is. So we saw that in these examples, in processing, there is more work done than in Arduino, just because the Arduino part is very simple. Like once you have the data, you send it out, there's nothing else to do. In the processing side, you first, we're gonna see step by step how the thing is being done. So on the one hand, we have the information as a string. We're gonna see how we can separate the information from the string. We will split the data in a better way, because right now it's just a string, but then we have to get numbers. Then we will graph it and add a legend, and then we will plot everything. So this is really meant to be done in a step-by-step fashion to make it very, very simple. So let's just take a look at the first example. So this one is, I don't know if maybe the typeface is a bit small. I'm going to zoom in just to make it easier for you to read. This one is the exact same as the basic server. It's just that instead of sending server message, it sends the message ping. But whenever it gets something, it prints it out. So basically this example is what we are doing right now, and it's not really useful. It's not adding anything new, so we're not even going to open it. The following example, sorry, is the one that is devoted to splitting the data into different parts. So this one here, besides doing the whole connectivity part as we did before, when it, oops, I'm looking at this now and I'm seeing that split data PDE is recorded by accident without the actual splitting data. So it doesn't show how you split. It's the exact same example as we have now. Okay, since it doesn't have the splitting part, which I made a mistake somehow, I'm gonna do the splitting data for you live. And then we can jump into the next example. Okay, so departing from the WebSocket example here, where we were reading data down here and printing it out, what I will be interested in is in separating the information that comes here, separated by commas. So whenever I have an event of receiving any information, I could print it, but I could also do other things on top. And this is what I'm going to do now. And as I said, I'm just going to do a bit of this code, and then we will see how it works and jump to the following example where we will already graph it. Okay, basically just to not to lose too much time. So there is this function called split, and split, what it does, it lets you take in a certain piece of code and separate it into sub-blocks. In this case, we have a string, and what we're going to do is to create a string of text, and the string of text is called MSJ, which stands for message, right? So we're going to split it by looking at the comma symbol. Okay. So this is the exact syntax. I'm all the time changing programming languages, and sometimes I forget. So split takes two parameters, which is the string you want to cut into pieces and the character they use as a separator. And what it's going to do is to create an array of different items that will contain each one of the bits and pieces of the string. For example, if I now print here list of 0, it will be printing just the temperature. So I could print something like temperature with a blank space and like this. If I run this example now, if the board is still connected, I should be, you see, it's printing out the first item coming from the list. So it prints the full list, because I still print message here, and then it just prints the first item coming out. I should actually have done print line instead of print, so that things don't get mixed up. So here you go. Okay. So you can imagine that if I know which each one of the items are doing, it's very easy for me to then just print things out nicely. So right now I have the temperature. Then I know the humidity is a second item in the list. So I could modify the code here and add here humidity. And this will be the item number 1. And the third one will be the barometric pressure. So I could just write here pressure, and this will be the item number 2, and so back and so forth. I remind you again, my board is constantly measuring all of these variables from the room and sending them over Wi-Fi, and the computer is getting this data through the Wi-Fi and then printing it out after parsing it out. Okay. So right now, this list 0, list 1, list 2, and so on, they're strings. This is an array of strings. If I want to use these numbers to draw something on the screen, I need to convert the strings into a number. So these are floating comma numbers. They have a comma or a dot in this case, or a period. So if I want to use them as a number, I should call them with the function float that will convert the string that contains the equivalent to a number into a actual number. So this, as a result, is going to make the exact same we just saw, only that right now it's an actual number, you know. Before it was a string, right now we made a number conversion. But the moment we convert it to a number, then we can use it for other things, like for example, changing graphical properties on the screen. You know, these numbers are very steady because the temperature and humidity and so on don't change dramatically or super fast. But I could do something about it, and I could use them to, you know, change the background color of the screen. I could use them to change whatever graphical property I have in processing, and I could be drawing something out of it. Obviously, the easy solution also is to try to draw some sort of graph that is plotting the information on the screen, which is what everybody or anybody will be interested in doing if you're getting sensor information from multiple sensors and you want to show it on the screen. So that's what the next examples in this code are doing. They're showing this step by step how these different things are being done. So let's take a look at the next example in the files I share with you from the repository to see how they are handling the data in order to graph it. So you back at the repository, and we go into the next sketch. As I know now this split data has a mistake. I need to change it later on. So let's see what add legend was doing. So add legend is already doing some more stuff. See, first of all, it starts the same way, imports WebSockets. It adds some information up here, but then it creates a whole bunch of variables, float variables, in order to store the data that we get from reading the sensor. So when we read the sensor, we send it in this long string, comes to the computer, and then we split it. But also it's adding all of the sensor information: temperature, humidity, pressure, illuminance, UVA, UVB, UV index, and CX, which is a counter that's used for counting what you're drawing. And then there is BID, which is something like beacon ID, like it's the ID number for the board. I remember when I told you earlier that my plan was to have multiple sensors distributed. Well, if I want to distinguish between different sensors, I need to have somewhere in the string of information a number that tells me this is the beacon number 1, number 2, number 3, number 7. So I need to add something to my Arduino code that is going to be helping me distinguish between the different boards. So that's what we're going to do next. First of all, we're going to change the Arduino code, and we're going to add that extra bit of information. And then we're going to come back here and see how we can use that data in order to grab something. This program is going to be printing something on the screen. Okay? It's getting the data and it's going to print something on the screen. So let me just stop sharing. And we're going to open the Arduino code that includes the number for the board. Oh, yeah. I could share so you can see the whole process. So here is my oops, what is my folder? Here. So here you see the folder for the Arduino code, and here's the many boards WebSockets. So this is the program for many boards, which basically just adds one more bit of data to the whole sensor string. So while it opens, I will just do the classic thing of changing the username and password for the network. And once I have it, I share the screen with you. Oh, I made a mistake again of not maximizing the window before I started sharing. Let me just share again here. And then I have to, again, copy the server information for the board. So it's the right server. If we take a look at the code, it's the exact same code as before. It's only that it's adding the board ID number. And here I put number 1. So it's going to add one more thing in front of all of the sensor information. I need to change the server name, server number to be the right server number. Everything is the same as in the previous example. It only differs that when it's sending the data here, it starts by sending the board number. And that's something you have to hard code for each one of the boards. So board number 1, board number 2, board number 3, and so on and so forth. I put this on the board, and once it's programmed, I can go back into processing and then show how the data looks like on the screen. Oh, sorry. There was an error because I forgot to close the serial port monitor from the previous example. So it was taking over the port. Yeah, let's do it now. Yeah, so this time works no problem. And so my board is running. I will just make sure it connects. To make sure it connects, I have to open the serial port monitor that you see here. The serial port monitor is open. It's connected to the server, and it's sending information to it. I can go back to the processing sketch that is looking at whatever data is coming from the server. 1 second, I don't know where I put it. Here. So now, if I run the sketch here, you will see that the first thing it's going to get is the ID number to the board. It's not the temperature any longer. You see, it's number 1.0. So I need to make sure that if I want to do something like this, I add here board ID, and board ID is actually an integer number. It's not a floating comma number. Like this. So as you see now, I can print the data and the board ID comes first. Okay. So obviously the next step is to start graphing this information. And that's what the next example we saw on the website is doing. So I will just open the example in this computer and then start working with it. So the Arduino example is looking like this. We saw it earlier. And this one is going to be getting this whole information and doing something about it. And in this case, if you look into draw, we're not just drawing a random circle, a random place like we saw earlier. It's actually choosing a certain typeface size and printing out the data straight on the screen. So if I run this program, it's going to start printing data. You cannot see this. I will share this particular screen with you. And please tell me if you see this, like now, right? So now you should be seeing this window that is printing the temperature, humidity, pressure, illuminance, and all of the other sensor information straight into the processing sketch. Well, this is the time where I have to say it's pretty cool, right? I mean, in less than an hour, well, a bit more than an hour with like a lot of like window changes and stuff, we went from, I have a board that is reading sensor information to, I have that sensor information being printed on the screen. So the next level really is to make nice graphs out of this information, not just printing it as a text, but making nice graphs. And that's what processing allows you to do easily. So the next example that we have for the processing side is the one that does that. And we're gonna dive into it and see how it works. And it's a bit more complex, it has a lot more functionality. So I would spend maybe like 10 minutes explaining how it works, and then I will open the floor for questions. Okay. So I will open the next example, which is just the next in line. If you remember looking at the different examples we have for processing, the last one is called plot data. And plot data is the one that is printing the data as graphs on the screen. So let me remind you step by step what we did. We got the data, sent it to the computer as a string. We added in the beginning of it information about the board number. We got the data, split it. Oh, this is one of those moments when my Spanish kicks in. I forget about the past for the verb split, to split. Anyway, you split the data because it's separated by commas, and then you store it into different variables, and we'll print it, those variables on the screen so we can see nice typefaced information about the data. Next step, plot it, make graphs of that data. Okay, so as I'm opening the sketch, yeah, it's opening there. So I will share the screen for the sketch with you here. And the sketch here has all of the birds and whistles for the whole example. So it has a bunch of arrays, because right now, if we want to plot the data, we don't want to just draw the current temperature. We want to draw the current temperature and the one a second ago, and the one 2 seconds ago, and the one 10 seconds ago. So we need to store that information somewhere. So what I'm doing here is that I'm creating an array that is 4 times as big as the screen width. So I can store a lot of data. So by the end of storing all data at the end of the array, it will start from the beginning again and rewrite it and so on. So you can play with this. I made it like this because my plan is to then make the whole thing scroll. That scrolling part is not working yet and so on, but it's enough to see the functionality. Then I choose a color for each one of the variables. So the temperature is going to be red, the humidity is going to be green, the pressure is going to be blue, and the other ones are going to be combinations of different values. Then I have 2 indexes. One is an index, W index, to see where I write data, because data arrives every X amount of seconds. And when it arrives, I need to put it in the next position in the array. And then I have the N index that is used to navigate, because when I draw, I need to go from the beginning of the array to the end of the array and draw each one of the points. In setup, I declare the window size, that is 800 and 600 pixels. I do the whole WebSocket connection. And I start this counter that is the one that I'm using for pinging all the time. So this thing is sending a ping every 5 seconds back to the board anyway. And what I do in draw is to say, make the background white, bring the data to the screen, or if there is no data, print no data. And then bring data to the screen is a function that basically writes the text on the screen, okay, like we saw earlier. I took that whole function that does text of the temperature, text or whatever, and made it into a function and put it into a single function. And then it represents the graphs for temperature, humidity, pressure, and so on and so forth. And this is a function, draw graph, that I created to be able to have in a single function to do everything. And it takes as parameters the array with the information, the color for the information, the coordinates where it starts, and the width and the height for the data, and which is the index they use to navigate it. So that function, WebSocket services as before, printed the screen, as I said, is just printing the information on the screen, or the temperature and so on. And then draw graph, as I said, is a bit more complicated. Is the one that is navigating through the array of data that is imported here in the function. And it's looking at the maximum and minimum value in order to paint it. And you will wonder, why does it look at the maximum and minimum value? Well, it does it because one of the main features of these graphs is that they have to be auto-scaling. You want the data to, I mean, if the temperature keeps on rising, you don't want the temperature like get mixed with other information on the screen. So you need the whole sum of the information to become smaller, so it auto scales and it fits everything on the screen. So for that, you need to actually take a look at which is the maximum value of the data, and based on that maximum value of the data, you map the information to fit into this piece of screen that you have available. So if I make this run, the program will start. In the beginning, it says no data. You cannot see that because I have to share the right screen with you. So let me just share the right screen with you. So it's saying no data. And for real, it also happened that there is an error in the code somewhere, because that's what I got. Let me share the screen with you so you can see the editor. And you will see here that at the bottom, there was an error because calling map in this case was giving us an exception. Okay. So I need to make sure that the data, that the Arduino board is connected and is sending data, and it's something I'm not 100% sure, because I think I had the WebSocket in use by a different program. So I have to just double check here, and I see that the board got disconnected because I closed the server. So the problem is that I had another processing program already running as a server, so I couldn't run a second server, so I couldn't get my board to connect to that second server. So therefore, I got an error. So I see that my board is not connected to nothing now. So if I go back to processing, to the right sketch, which is the plot data sketch, and I open it again, it should somehow start properly, but I think I'm having an issue here. Yeah. Oh, no, now it worked. Sorry. Yeah. So let me just share the screen with you. And if you start everything properly and not make the mistake that I made of like forgetting to close the previous program, here you have how the temperature, humidity, and so on are being plotted on the screen. And you see I put a legend here to make sure that each one of them has a different color so that it's easier to read through it as you look at it. So here you see, it's a fairly easy process to go from sensor information to graph something This is the first step to build your own IoT, because in order to build your own IoT, basically what you want is to have data that can be represented or visualized somehow that can then give you a different understanding of what's going on. You don't need to go to any weird clouds, any kind of things. But of course, this is just constrained to the, I don't know, 20 meters of coverage that I get from this Wi-Fi network that I have here. If I wanted to be able to check in these things while I am somewhere else, I would still need a cloud service, and there's multiple cloud services that include things like apps and so on. We at Arduino have one that is really cool that you can check for free, by the way. But if you want to build your own personal secure internet for your own monitoring services, this is a very easy way to get started. Okay, so I will now stop sharing my screen, and I spoke for 1.5 hours straight. So I will open the floor for questions in case there is any questions from any of you. If you don't feel like talking, you're more than welcome to also just write questions in the chat, by the way. So it's perfectly fine. I will read the question aloud and answer. Okay. One question is, how far can this particular board, the MKR1010, transmit Wi-Fi signal to the server? So that's always about the combination between the access point and the board. You know, if you have an access point that gives you 150 meters coverage and the board happens to be the coverage area, then you have 150 meters. So it depends on that scenario. The MKR1010 board has a really, really good antenna for Wi-Fi. So if your access point gives you long distance, you get long distance. Right now, I'm connecting through the Wi-Fi of my phone to make this connection reliable throughout this whole webinar. So my phone, I think, has like about 20 meters. I estimated it one day, 20 meters coverage around the phone. So it's not a lot, but it's not because of the board. It's because of the access point. Any other questions?
I have one, but there's another one that popped up here on the chat. I don't know which one you want to go for first.
Yeah, but since I started to talk, just bring your question in, and then I will answer the questions that are showing up in the chat anyway.
Great, David. I want to ask a question that's maybe a little bit not so much overlap with the session. I think there's some, but it's not that technical. It's just talking a little bit about in the Fab Lab network, right? There's this big push for making our own boards, and that being a big part of the conversation. I don't know if you want to kind of give us your take on that, like to what extent does that make sense, to what extent it doesn't make sense. You know, as we saw here today, this is, you know, there's a lot that you can do with very inexpensive things that you purchase, and kind of the bar is lower, right? If you have an entry-level thing, solution that you can.
Yeah, well, I'm a strong defender of learning everything. And I know that in the Fab Lab network, of course, there's this philosophy that started by Neil Gershenfeld of doing everything by yourself. And I think that learning how to make a board is a really good thing. And I will invite anybody to try it out. I know that a lot of people inside the Fab Lab network made their own Arduino Uno-based boards, which I think is great. You know, it's an open source design. You're more than welcome to use it any way you want to. And it's a great learning experience. And I think everybody that are interested in embedded technology should try to at least make a board once in their life to understand all of the process from choosing architecture, checking the bootloader, basic code, the core, and all of these different things that are part of building your own system. Then after that, the philosophy we're trying to follow in Arduino is that more and more people just need easy connectivity, like, oh, I need LoRa connectivity, I need GSM connectivity. And so then you can do a similar thing by just getting boards like the Maker family, for example, that offer you like multiple connectivity possibilities, and then make your own carrier board for the specific project you're building. You're building like a, I don't know, greenhouse controller, and you need the servo motor and a pump and a couple of more things. Then build the physical controllers in that one and use the Arduino with the Wi-Fi, for example, if you have Wi-Fi coverage, and if it's in remote location, use Arduino with GSM, so you can still, you know, make the same carrier don't work twice, because connectivity is becoming such an important thing, and also testing in the lab versus testing on field, and so on and so forth, right? So yeah. So that's my philosophy, but definitely everybody should try making it work. I think it's relevant. Makes a lot of sense and helps you understanding a lot of things about electricity that reading them in books are really, really boring. You know, as an engineer, I can tell you. Okay, let me ask the other questions. Adam has a question. Processing is giving an error that WebSocket server is pointing to 000, can't connect. Well, if you have that, I will ask you to check things like first of all, which operating system you're having. The operating system matters, but I have tested this both in Windows and Linux, and it worked fine. I'm pretty sure the library was written by somebody with Mac, so it should work fine. I would check things like firewalls and stuff. Troubleshooting this is always the complex part, by the way. Then it's another question about whether there is a difference between Arduino Nano 33IoT and the MKR1010. Yes, there is a difference, and I don't know if I have a Nano right now here, because I was traveling and I mixed up all of my boards. But the idea in the Nano boards is to make them as cheap as possible, really, like adding the functionality as cheap as possible, sacrificing some stuff, but also adding a basic thing, which is motion detection. So all of the Nano boards, except for the Every, have an accelerometer of sorts. So the Nano IoT has an accelerometer. So you could do things like a step counter and things like this out of the box. But it doesn't have battery plug, and it doesn't have battery charger for that matter. So if you are okay with having like an external battery system with like a small power bank, then the Nano IoT is as good as the MKR1010. You know, it's just cheaper. If you really need a project where you're really in the need of the battery thing, then the Maker is your board. If also there is one more difference. The MKR1010 can run as a USB hub, but none of the Nano boards can be USB hubs. So if you have a need of making the board a USB hub for some weird reason, which very few people have that kind of need, then the MKR1010 is your board. Both of them have Bluetooth Low Energy and Wi-Fi. And there is a hack on the net somewhere where on the MKR1010, somebody got to work the Wi-Fi and the Bluetooth at the same time, which is a really cool hack. So yeah, there's another question here. When to use the ESP32, which is a lot cheaper, more memory, hardware encryption, etc. Well, ESP32 is what is inside the Wi-Fi NINA module. It's only that it's certified. So these boards have FCC and CE certification, and they have an ESP32 module from a company called uBlocks. There's also another thing, and it's at the Maker board and another board, they have a cryptographic chip that other boards don't have. So if you want these things to connect securely, which is, as I said, something I was not covering in this workshop because that's a very complex thing to explain properly. But if you want this thing to connect securely, for example, to the Arduino IoT cloud, you need to have a crypto chip or it's not going to fly. So crypto chips are used to negotiate certificates, do HTTPS connections, connect to things like AWS and other kind of things. But of course, the ESP chips are fantastic. They do a lot of stuff. Mm-hmm. Any other questions? Okay. Well, since there seems to be no more questions, I'm glad we got the chance to do this introduction. As I said, it's the second time I do it. I will say keep posted to the repository because I will keep on adding. As I said, my goal in a couple of months should be to end up having how to build the server running on a small Linux computer, a LAMP server, you know, Linux with Apache, MySQL, and PHP. So we have a small API for people to like exchange data from their boards on this one. Everything I did can work on other boards with other connectivities. You're more than welcome to do whatever, but I use the boards and the tools that I design, so I feel more comfortable with them. And that's it. Thank you so much, and see you all on the internet.